this lecture. Okay. So I want to share my desktop for this lecture. Now okay.
Yeah, now okay.
And this is the schedule of this 2 or 3 weeks. And okay, so screen okay.
Yes, okay.
I should make it more larger.
Yes.
Okay, this side okay.
Yes, okay. We
Or oh, this
yes.
is better.
Yes.
Okay,
Just
this
like
is
all.
a schedule of the 2 or 3 times lecture. Then at first, I want to talk about my master thesis nearly 40 years ago. My master thesis is to develop a new method for cation exchange capacity of soils. Do you know cation exchange capacity?
Yes.
Yes or no? Please say yes or no, students.
Yes. We understand
Yes. Yes.
We understand about ion capacity, Prof.
Yeah. Cation exchange capacity is the index of the fertility of soils. But conventional methods are time consuming. Then I developed a method using strontium and hydrochloric acid. So at first, this is a soil. Soil has negative charge, and cations are absorbed to compensate the negative charge. The amount of negative charge is a cation exchange capacity. And usually, ammonium ion is used to replace and saturate negative charge. Replace cations and saturated by ammonium cation. But I use strontium cation. This is why this is because strontium ion has more strong ability to absorb negative charge. Now I want to ask you about the selectivity or strength of absorption of cations to negative charge. So there are 1, 2, 3, 4, 5, 6 cations. Do you know the order of the selectivity or absorption strength of these cations to negative charges? Yes or no? Please say. Which is the most strongly absorbed? Do you know? Yes or no?
Hello. Would you please?
Maybe no, Prof.
No? Okay, so later I will explain the absorption selectivity of cations onto negative charge. My method uses strontium, the saturation or index cation. After that, the strontium is replaced by proton once washing. Usually, the replacement of ammonium ion is done by potassium ion 5 times. Then, in my method, strontium is replaced by proton and released to the solution. And the strontium released to the solution was absorbed by atomic absorption spectrophotometer. Then CC is calculated. In the traditional method, using ammonium ion cannot be determined by then they need to determine by some complex method. I have never done. Then this method is very quick, easy, and not time consuming. This is my master thesis about 40 years ago. Next, alpha. Do you know alpha?
Yes, we understand allocation. Yeah.
Do you know? Yes or
Yes.
no? Please say, students.
Yes.
Yes? Okay. So I determined the whole chemical structure of alpha. Alpha was, the whole structure was not known. Alpha is a complete crystal. Complete crystal means, for example, a two-dimensional crystal or three-dimensional crystal, such as quartz. Quartz has the broken edge. But alpha has no broken edge, complete crystal. And the known facts are alpha is a hollow sphere, diameter 5 nanometers about. And the structure of the wall, the same structure as immobile. And several holes exist. So this is a ball or baseball. Baseball play. So similar structure of this. But whole structure was not known. Then I assumed octahedron expanded truncated octahedron. This is octahedron. This is truncated octahedron.
Okay.
And by expanding this, become a ball, hollow sphere. So this is the allophane whole structure. I input into the computer about 3,000 atoms. Consist of silicon, aluminum, oxygen, hydrogen. And the whole structure was optimized by quantum chemical calculations by using supercomputer. So this is a whole structure of alpha. At the pole, SiOH, LOH is exposed. In the inner surface of the wall, SiOH exist. Then alphen has many SiOH, LOH. They are chemically active. So alphen is a very chemically active mineral that can absorb heavy metals, anions, phosphate, and so on. So this is the introduction of the structure determination of alphen. And there are any questions? No? If you have questions, please say in any time. Okay, so
Yes.
no question.
Okay, bro.
Yeah.
Okay, bro.
Yeah.
Yes, bro.
Okay, please, student, if you have any question, you did.
We have not for this moment, bro. We have no
Okay.
question for this moment.
Okay, so
Okay, maybe continue, Professor Matsui.
yeah. And then next I want to introduce my final research, ATA foil. ATA foil as a DIY sterilization tool for underserved communities. So this article will be published in Science of the Total Environment in 2 or 3 months.
Prof. Matsui, maybe
Yes.
I will ask you. You mean about DIY is do it with your own risk or anything else, Prof?
Okay,
I'm so
so
sorry.
I will explain in more detail from now. Okay, I want to explain this research in more detail in the next slide. Okay, do it yourself. Very easy method. Before going to the next slide, I want to introduce my rich life. I have a car. Do you have a car? Yes or no? Please say yes or no. Do you have a car?
Car, yes,
Mo
yes.
Mobile,
Car.
mobile.
Yes, yes.
Do you have?
I do. Yes, I have, Prof.
Because I am very rich, my car is very excellent. For example, window automatically down and up. Very nice car, but very cheap. And also, I live in very rich house. For example, I have a machine. The machine, the cold wind or warm wind come out. Air condition. Air condition. Do you have air conditioner?
Yes.
Yes or
Yes,
no?
I do.
Yes.
Yes,
Oh,
yes.
you're also rich people. And also, water, clean water, tap water. I have tap water. In addition, warm water coming from the tap water. Do you have tap water in your house?
Yes.
That
We have.
can drink without
Yes.
treatment? No treatment, the tap
No,
water.
no treatment.
No treatment because we have water on package, see, Prof.
In Indonesia, they buy water for drinking.
Yes, we buy the drinking water on package, Prof, on box.
We
without the treatment.
Japanese can drink tap water directly. So I think tap water in Japan is the number one of the world. Safe water. So then Japanese are very happy to get safe water very easily. More than 98% of Japanese people have tap water in their house. But this is Japanese girl. She is going to school besides the clean river. I don't know who she is, but she is going to get water
Water resource, maybe.
for their family, for drinking or cooking. She cannot go to school. This is another photograph. They get water for drinking and cooking besides the animals.
The
Pushing.
coal. Coal.
Very, maybe that
Maybe the bison, Prof.
they are somewhat happy. They have this kind of way. I don't know who she is, but this is African household. My target is this water pot for drinking or cooking. This is data from WHO homepage. Now I want to temporarily stop the sharing. So if you now internet, okay?
Okay, Prof.
Yes.
Okay, our internet is
WHO.
okay.
WHO. Both okay. WHO drinking water. You can find easy this page. Updated last year. At least 1.7 billion people use. Do you know the world population?
Wow.
World population is 8 billion.
Yeah,
World
8 billion.
population is 8 billion. But
Yeah.
1.7 billion people use a drinking water source contaminated with fishes. Do you know fishes?
Yes.
Then contaminated by microbial contamination. And according to WHO, 500,000 people, mostly infants, die each year.
Excuse me, Professor Matsue.
Yes.
Are you still share your slides, because there is no slides.
Oh, now internet page? No.
No.
No. We have
No.
good
You
internet
have
access,
not-
Prof.
You have not share your
sorry.
slides.
Sorry,
Yes.
I stopped.
Yeah, no problem.
Oh, okay. I
Okay,
mistake.
okay. Now, yes, no.
I'm sorry. I mistake. Now okay.
Yes,
Now internet. Yes.
yes, it is internet.
The keyword WHO,
WHO,
drinking water.
Yes.
Then you can find this page very easy. Now okay.
Okay.
I'm very sorry. I mistake.
No problem.
African ready. Now okay.
Okay. Yes, drinking water. Yes. Mhm.
Last year, September. Dead.
Yeah.
1.7 billion people use drinking water contaminated with species.
Yes.
As a result, 500,000 infants, mostly young children, die each year. So this is a big issue. I think this is a very big issue. The WHO data said 0.5 million, but another organization reported 1.5 million each year. Then I wrote here 1 million. Anyway, very large number of people die each year. And the main cause is waterborne pathogen like E. coli. Then I want to make a tool to disinfect the water of the household water pots. So this is an example of water in Africa. The student, my student in Africa, sent me the photo. This is the water, Abela. And this is the water purified by Stefan. This is a very popular machine in Western countries, but very expensive. So she said, I have this, but neighbors have no money. Then they drink this water. And this is from Malawi. This is the water content bucket. They put water in the bucket and use for drinking. So the both is very not nice water. This is a reality of one story. I cannot see the top. What is the top? Yellow. Can you read this one?
Yes, infrastructure like tap water.
I cannot read this one by the this black tape.
Yes.
Infrastructure like tap water is not maybe not constructed in 10 years, plus 30 years. Then they use HWT method, household water treatment method, like chlorination, filtration, boiling, so this. Do you know so this? No? Do you know
What
so
is
this?
so-
Yes or no? Please say.
So
Okay,
this
I will explain. I will explain. Now, very nice error. We can know everything from internet.
sorry.
This is false. False. えーっと、
Profner, maybe in Indonesia we say it about water RO, Profner.
solar
I think
infection.
Kata-katanya kan maksudnya itu
This is okay.
maksudnya seperti itu.
Pet bottle, water, and at least 6 hours sunlight, then become disinfected. They say, but this method is not so effective. Many research reported that this method is not realistic because 6 hours is very difficult for many people. Okay, so this is a solar disinfection.
Yeah, okay.
And
Thank you.
sorry, you have two questions.
Yes, it's okay.
Thank you, bro.
Okay, I can continue.
Yes, please continue.
Okay.
Yes, please, Pak. Yes, please.
These methods are classified as DIY and non-DIY. Do you know what is the difference between the two groups? Why this is DIY? Why this is non-DIY?
Maybe chlorination use some tools, maybe, bro.
Iya, betul.
Filtration use some tools, but DIY with our action, we use the solar by the environmental. And maybe this we say about non-DIY and DIY.
Yes, that's right. For chlorination, they need chlorination reagent tablet from government or in the market. They must buy, but poor people cannot buy. And filtration, like the Stefan.
Okay.
They need the machine for filtration. But boiling everybody can do boil. And everybody can do the solid without special material. So then I classified into DIY and non-DIY. Okay, can I go to the next?
Yes.
Yes.
But this method has a default. For example, chlorination, very bad taste and odor. Maybe in Indonesia, chlorination is not popular.
Yes, we don't.
Yes, I know that Indonesian people do not use chlorination. But in many countries, they use chlorination. Many governments recommend to use chlorine reagent. But the taste is very bad. Then
Yes.
they will not do chlorination and become disease. For that, taste and odor is very big issue. And also need reagent. Filtration. Machine apparatus is very expensive. And they can do filtration by DIY using stones or anyway, DIY filter. But they're not sufficient. Boiling. In Japan or in Indonesia,
Yes.
it is very easy to boil for 2 minutes. Do you agree to me?
Yes.
Yes.
We are every day we boiling water
2 minutes.
for our drink.
2 minutes boiling is very easy in Japan, in Indonesia. But I asked some African students, they say that 2 minutes boiling is very difficult because they have no fuel and no food. Then they say 2 minutes boiling is very difficult and time consuming. And also they must cool down the water after the boiling. Then boiling is very effective, but not so easy to perform. For this, as I told you before, 6 hours sunlight is very difficult. And some research report showed that this study by the residents, by the people, was not effective because 6 hours strong sunlight is very difficult. Then our goal was to develop the method that can be easily performed, meaning DIY, at room temperature. And it will not impact taste or odor. This is my goal. And the goal was achieved by the ATA point. So before reaching to the ATA point, I developed key bacteria by Europeans. So this is a scheme of disinfection of bacteria by using zeolite, modern,
Yes.
on which proton is retained. Or silver kappa is adsorbed on the surface of the molybdenite. And the molybdenite is heat embedded on the unwoven fabric film. anyway, proton retaining zeolite sheet. This I succeeded to kill bacteria by using this sheet. Because the pH of the water dropped to 4 or 3.8, weakly acidic. At the acidic condition, bacteria was killed by the low pH. But I want to introduce my article. This is an article. Modern embedded sheet
Yes.
in bacteria. So Blanclan increased by about 10,000 times after 24 hours, but the sample decreased. But African people said to me that I don't want to drink acidic water, pH 4. How about you? How about the students?
Yeah,
Can you
of course.
drink water of pH 4 or not? Yes or no? Please say yes or no.
Ini di bawah atau tinggal sini?
Water in African country, Prof, or Indonesian country? Water in Indonesian country.
Can you drink water of pH 4 or not? Yes or no?
Water by what, Prof?
pH 4, low pH water.
Oh,
pH
Low
4.
pH water.
I
Acidic.
can't. No.
Yeah,
Yes
acidic
or no?
water. We don't want.
No, Prof.
No?
For pH, I was see water with the pH is 3 on mine acid drainage, Prof. And then I so scary for drink the water with pH is 4.
Then maybe so. But in Japan, we drink vinegar. Can you believe? And
Really,
also,
Prof?
do you know the pH of Coca-Cola?
Yes. I know about Coca-Cola is pH is 4, 5, and
No.
then
pH of the Coca-Cola is very low, lower than
Yes.
3.
Yes, Prof.
And do you know the pH of lemon tea?
Yeah. Yeah, acidic.
Acidic. There are many acidic drinks.
Yeah.
So, and also the WHO stated that low pH water is no problem. But African people don't want to drink acidic water because their water is usually alkaline.
Okay.
Then I give up this method because they don't like acidic water. Then I give up this method. Then I going to the second method, absorption of bacteria by LDH. LDH is a aluminum magnesium layered double hydroxide. Do you know this mineral? Yes or no, please? Do you know LDH?
I know about
Layer double
aluminium.
hydroxide.
Itu
Sorry, internet.
Yes, we can see.
LDH, sorry. I mistake. This is LDH. Very similar structure as montmorillonite, but montmorillonite has negative charge, but LDH has positive charge. LDH can absorb an ion.
I see.
Anyway, after this lecture, if you have interest, you can study about LDH. I back to the slide.
Yes.
Aluminum foil, the surface is covered by oxide. Do you know?
Yes.
Aluminum very quickly oxide. And the surface is covered by oxide of about 1 micrometer. Putting aluminum foil into alkaline water, the oxide phase dissolved. Then metallic aluminum exposed. Then magnesium react with aluminum to form LDH. Then LDH foil is produced. Very easy procedure. Just put aluminum foil in this solution. We can obtain LDH foil. His innovation, how it is. From Andhras University. My wife. Me.
Yes.
And this is a graphical abstract. Aluminum foil to alkalize magnesium solution can obtain LDH foil, and putting LDH foil into water absorbed, then clean water is obtained. This is LDH foil.
So, may I ask you about the result of the water pH after treatment? The pH of the
no.
water after treatment.
No change in pH. This oil does not affect pH of the water.
Okay.
And also, LDH is also used as medicine, safe material.
Yeah, okay.
Okay?
Okay, thank you.
Okay, so if you have a question, anytime you can ask me a question. Now I can go into the slide 20. This method is very easy. For example, again, the article. Many methods, many alkaline solution and MG solution. Just mixing the two solutions, we can get ATA foil. But adjusting pH and magnesium concentration is easy for us, for researchers, very easy. But people, maybe usual people, may be difficult to adjust pH or magnesium concentration. They will make mistake. Then this method is non-DIY. My research was not complete. A final method, very easy method. DIY means very easy by using not special material. Absorption by aluminum hydroxide. This is the salt component. Do you know aluminum hydroxide? ALOH3. This is also contained in soil. Last summer, we found that magnesium is not necessary. Aluminum foil immersed in alkaline solutions absorb acid. This is a new discovery. This is a preparation method of ATA foil. Just the pH is important. pH 10 to 11. 9.5, 12 is also okay. Aluminum foil, oxide dissolve, and metallic aluminum react with OH to form ALOH3 coating. This is ATA foil, alkali treated aluminum foil, ATA foil.
Okay.
Outline of the ATA foil creation. Immerse aluminum foil in an alkaline solution with a pH of 10 to 11. NaOH, Na2CO3, CaCO3, CO2, MgO2, MgOCO3, NH3, all okay. Any alkaline solution okay. If the pH is 10 to 11 or 12. But using MgO2 or MgCO3 makes it much easier to create the alkaline solution. They contain magnesium, but LDH is not formed. because the concentration is very low, 0.1 millimole per liter. Lowers. The solubility of MgO2 and MgCO3 is very low. It means everybody can create saturated solution. For example, 1 gram per liter, 10 grams per liter. The both suspension. The pH is same, 10.3. Because saturated solution, in the saturated solution, composition of the water phase is constant. Again, I explain again. In the saturated solution, pH and magnesium concentration or water phase composition is constant at 1 gram per liter or 10 grams per liter suspension. This is the details of HFO relation. Add MgO2 or MgCO3 to water. The dose does not affect the effect. This is not a joke. Dose does affect effect. This is not a joke. Dose does not affect the effect. Then immerse aluminum foil. Placing aluminum foil in a net is convenient because aluminum foil is easily break down. Leave overnight or for 24 hours. Stirring is not needed. 1 week is okay. Wash with water to remove attached white powder. But MgO2 is also medicine, safe for human. So no washing is also okay. Put into a water container. Stirring increases GFL. Renewing the HFO accelerates the source. So the number 6 is very important. Used aluminum foil, again, immerse in the magnesium suspension for 1 hour. Can be generated and can be reused. So this is the scheme. Aluminum foil in the net, magnesium hydroxide suspension. Put, wash with water, and put into the water container, water pot, to absorb bacteria, microbes, and clean water. Then the used oil is regenerated and reused.
Nice.
So this is my
it can be used. So it can be reused again by
yes.
immersing in the suspension again. Okay.
Yes, because the pH of the suspension is 10.3. Then the bacteria absorbed on the oil is killed by the high pH. Then disappear. Then can be used again. But because we have no time, how many times? How many cycles? We tried up to 3 times, but 10 times, 100 times. So this is a future work. Anyway, regeneration and reuse is possible at least 3 times. So this is my final research results. This is conditions of our experiment. And this is the blue is a blank, increasing with time. And this continuous means not linear, no linear. No renewal is less effect. But once the red one, once replaced after 24 hours, decrease after 48 hours. 4 times renewal. 1 hour, 3 hours, 6 hours, 24 hours, added new point become 0. The blank line increase from 1000. So then renewal, replacement is very important. This is the effect of wash, steering. No mixing, similar to blank. One mix, continuous mixing. Anyway, mixing is very important. But only one mixing is also so next is the mechanism of the adsorption. Bacteria has phosphate groups on the surface. I asked some specialists of microbes. They said all microbes and virus have phosphate groups on their surface. And the ATF LOH reacts with phosphate groups. LOH reacts with phosphate groups. Do you know this reaction? Yes or no? Please say, students. Do you know this reaction? Yes or
please.
No?
Yeah, please answer.
Yes. Do you know this reaction? Yes. This reaction.
Do you need any explanation? Yeah.
Yes. This is
Yeah.
maybe
Yes.
you studied from the professor.
Yes.
LOH
Yes, of course. Yes.
Is phosphate.
From clays.
Reaction.
Yes.
This is a very famous reaction. The same reaction occurs between ATF oil and bacteria. This is a knowledge of soil science.
Very, very good knowledge.
This is a knowledge of high school.
Yes.
Al2O3 reacts with OH minus, alkali, and dissolve. And aluminum, metallic aluminum reacts with OH minus to form LOH. This is the knowledge of high school chemistry.
Yeah.
So this is the knowledge of soil science.
Yes. Yes. I know. Yes.
And another mechanism. Bacteria surface is negative. And this is not true. LOH, mistake. Not only binary, also LOH. LOH become LOH2 plus at low pH. Then positive, negative interaction. So this is a variable charge in the soil chemistry. Variable charge. SiOH, SiO minus, AO2 plus is very famous in soil chemistry. So this is the knowledge of soil chemistry.
Yeah.
And I'm sorry, very long explanation for ATF.
Yeah.
Because I will retire this the end of this month. I retire. Then this is the final research of my research life. This is the merit of ATF oil. Easy to make using disposal, aluminum foil and magnesium hydroxide, which is also fertilizer. The creation method is simple and easy. Some mistakes will not affect the performance, meaning DIY. Anybody can produce ATF oil. To disinfect, just put in a water bottle or bottle at home. We checked the elevation of aluminum, but very low. The effect increases with stirring and depressing. It can be regenerated and reused simply by immersing it in the suspension used for the creation. User-friendly, eco-friendly, sustainable.
Yeah,
This is
yeah.
the
Sustainable.
speed.
Yes. Easy without machine.
This is a free technology, no patent. Everybody in the world can use this method.
Oh, thank you very much. No patent.
Because the technique, this technology is for poor people. we cannot get money from poor people.
Yeah.
Then this is a free technology. And will be published in the journal. So we found that LOH3 absorb bacteria. This is a new finding. Anyway, so this is a repetition of the previous slides. And the lady again come. ATF oil put into the water pot, then absorb bacteria. Similar to the boiling method, it can be performed by anyone, anywhere, making it possible to conduct verification experiments using local water anywhere in the world. So please use anyone, but verification test is important. After the test, they must use. Because we only checked by E. coli, Salmonella, and anyway, we checked only 3 kinds of bacteria. And the effect depends on the temperature and water quality. Then I must say that verification experiments should be conducted before using this method. So this is the introduction of myself.
Yeah.
And the second, I'm sorry, this lecture, 90 minutes? 1 hour? 1 hour or 90 minutes? When I should finish? 60 hours or 90 minutes? 60 minutes? Or 90 minutes?
Yeah, it depends on you. So please, if you still have time, so please until this slide, the completely slides, it's okay. Please.
In Japan, 90 minutes. In Indonesia, also 90 minutes. One and a half hours.
Yeah, 1.5 is okay.
Okay. We have another 20 minutes. So okay, thank you very much. I will move to the second.
Yes. Okay, thank you very much for your very nice science. So the application of the soil science to environment, environmental science and environmental technology. And I think it is very important for us that we already study about soil science, especially here in soil chemistry, and then mineralogy, and then, but sometimes we don't understand about how do we can apply, about our knowledge, especially in soil science, to the application for the daily problems, like about the bacteria in the water, and also about the anthropology, because so very different between Japanese people, African people, and also Indonesian people. How do we can consume what kind of water? So now I understand that African water don't like the acidic water for drinking. But maybe for the Japanese and then Indonesian, we drink like acidic drink, like lemon tea and so on. But for the others, not do not like. So by this way, Professor Matsui, that how do we can develop from the basic soil science, basic mineralogy, that we can apply. We can apply to the other problems, like environmental problem, about, for example, today, about the bacteria content in the water. So by applying the aluminum foil treated with alkaline or ATA, so the reaction is like, how do the phosphate, the phosphate can react with the aluminum hydroxide, aluminum hydroxide. So it is the basic the basic soil chemistry, and also about the variable charge, the variable charge theory, that how do we can kill the negative charge bacteria. So it is very important for us. How do we can develop from the basic soil science? How do we can apply yeah, to the other problem, to the other material like water. Yeah, so we can give very very important, yeah, especially for the beneficial for the benefit of the knowledge. So please, for students and also for our colleagues, for our lecture in UPN, if you have any questions or maybe comment, so please by raise hand, please. Yep. So please, if
Thank
any
you
question.
for Prof. Matsue for open mind of our for solar water, right, Prof. This
Hello, please. So please, Yudi,
nothing,
do you have
Prof.
any question?
Thank you
Yes.
for Prof. Matsue. Nothing, Prof. Thank you, Prof. Thank you for
No
knowledge.
question? There is no question from you?
No question, Prof.
Okay.
No,
Okay,
nothing,
thank you.
Prof.
Maybe Pak Rusli, all of you, if you have any question, please you speak in Indonesia and then I will translate into English and maybe sometimes also some words also in Japanese, maybe sometimes. Okay, please.
Yeah. Thank you, Professor Professor Nur, Mr. Professor Matthew. I have a little question. We have previously explained how to use mineral material to clean polluted water. One type of mineral used is zeolite, maybe. Are there other types of mineral that we can use to purify water? And how practically to make foil? Maybe that's my question. Thank you.
Okay, please, Professor
I
Matsui.
think you have many natural zeolites in your country.
Oh,
And so if you have Montmorillonite,
yeah.
Montmorillonite is also a good material for absorbing heavy metals.
Yeah. There's many zeolite in our country. There's in Java Island and the other Sumatra Island, spread in several country, several yeah. Zeolite is many in Indonesia.
Natural zeolite is very nice because very cheap.
Yeah.
Yes.
So among zeolites, the cation exchange capacity is depend on the aluminum ratio, Si to A ratio. So high CC zeolites and low CC zeolites.
Okay.
But most zeolite natural is low CC zeolite, but because the price is very low, low CC, but okay,
Yeah.
because the prices are very low.
This, my question too is how to make the foil, Professor. How to practically make the foil, foil.
Very easy. Just put into alkaline solution.
Practically.
But in case of calcium hydroxide, calcium carbonate, the calcium and aluminum makes CaH, calcium aluminum hydride. calcium and aluminum bind to form CaH. CH is a calcium aluminum hydride. This material is easily detached from aluminum foil. Then, when you use calcium hydroxide and calcium carbonate, the reaction time should be less than 1 hour. So we described in the article. So I can send you the article after published. And also sodium hydroxide, sodium carbonate. In case of sodium reagents, the concentration of the sodium reagent is important. But we didn't check the appropriate concentration. You must check which concentration range is okay.
Yeah, thank you very much for explanation. Thank you, Mr. Professor Monsieur.
Thank you very much.
So, any question from, yeah, please, Dr. Joko. So please, if you have any.
Yes.
Joko-san,
gozaimasu.
こんにちは、Joko-san.
Yes. Ohayou
Yes.
gozaimasu.
Ohayou
Masu
gozaimasu,
sensei.
Prof. Joko.
Yes. Yes. I would like to ask about the condition of bacteria after adsorbed with the formula. It still survive or almost die? Thank you.
Sorry, I couldn't understand your question.
About bacteria adsorbed. Can they still survive or almost die? Thank you.
So bacteria adsorbed on ATF oil is not killed. Just adsorbed. Still living on the surface. Then they must kill bacteria attached to by putting into the magnesium hydroxide suspension.
Okay.
Okay. My answer okay.
Okay.
So please,
Thank you very much
for your question. So please, if you still have any question.
Okay, so if you have questions by email.
Okay. So if
By email after this lecture. So
yes.
Can I share my slide? Okay. So for the next week, number 3.
Yes.
Chemistry of aqueous solution, hydration, activity, pK. Do you know hydration, activity,
Yes.
pK?
Hydration, activity, and then pKa. Yes.
Yes. Professor always lecture. So this is not needed.
Okay.
No, I should delete the yellow one because
Yes.
you already know. Hydration. Okay. So this is very important. So next week we start from this hydration, activity, and PK.
Okay.
And also overlap with the professor's lecture. So I want to start from this next week. Okay.
Okay. Yeah. So very thanks, Professor Matsue, for your lecture today. Yeah. Very interesting from especially from your research that we can apply. Yeah, we can applicate from the soil chemistry and then mineralogy like olefin. Yeah, to the how do we can overcome some problem with the low cost tactic. Yeah. How do we can kill the bacteria from water that we can drink safely? Yeah, I think very important. Yes, and then yeah, I hope that for next week, yeah, we can continue, yeah, about the hydration and then about the activity and then PTA for next weeks. So we hope that with we in the healthy condition that we can meeting for the next week in the same time. Yes. Okay. Thank you very much, Professor Maxwell.
Very much.
So if you
Thank you very much.
have any activities, so yeah, please if you can wait for this meeting. So please maybe the the remark from you for us. So please.
Okay.
Thank you very much,
See you
Mr.
next week. Thank you very much.
Professor. Yeah.
Okay, see you next week.
Okay.
Siap.
See you.
very
Bye
much.
bye.
Arigatou gozaimasu.
Okay,
Thank you very much.
Thank you.
thank you very much.
Siap.
Oke, mungkin kita masih sedikit ngobrol lah gitu loh. Halo,
Iya,
mungkin
Pak.
bisa
Siap,
di
Prof.
ini ya. Iyalah, masuk kita ini. Tadi yang
Iya,
sudah
Prof.
keluar siapa
Di
ya?
summary kan, Prof?
Iya, oke.
Tahu, Prof. Mungkin sedikit summary-nya aja, Prof. Karena kalau
Iya, iya,
sudah
iya.
berbicara
Oke.
teknikal tadi saya ampun-ampunan, Prof. Kalau sudah masuk ke K+,
Enggak.
H2, terus itu tuh sudah. Tapi satunya yang sodis itu ternyata ya low cost
Oke,
and
ini saya tulis
DIY
dulu
itu.
untuk ininya ya. Halo, ini kan recordingnya saya tutup dulu nanti kita ngobrol.